Alrighty, one last video on this Unit 2 review problem, where we're looking at the meanings of asymptotes and how we can use them to help us either draw graphs or solve problems in context. Looking here at numbers 5 and 7, I'm going to actually skip number 6 because I think we did this in class, in almost all classes. So, focusing here on number 5 and 7. The cost for printing t-shirts is made up of a flat fee of $70 and a cost per t-shirt of $2.50. So I see it in this equation. Looks like they put the flat fee second, but since addition can happen in either order, it's not going to change the answer. We can write that $2.50 per t-shirt plus 70. Doesn't matter which order we put that in. So the cost is a function of the number of t-shirts printed, x, and can be modeled by C of x equals 2.5x plus 70 over x. This first one asks us to convert the function into the form px plus r of x over b of x. So this is telling me I need to actually do the division. Do the division. If you were working this in the grid format, we would see that we have a first degree polynomial in the numerator, so I need one column, and I'm only dividing by x. So it may seem kind of strange, but we're looking for something that would have a 2.5x, and then on the outside looking at 70. The only thing that can multiply by x to get to 2.5x would be 2.5. So that's our actual p of x. There's our product going on there. So 2.5 is the product, and the remainder, remember that's what's going on outside. I don't have anything to multiply that 2.5 by, so everything in that 70 is the remainder. So we would have 70 over x. Now you've also seen me do this if you've watched my previous videos. Just by writing this as two separate fractions. So instead of the same having a common denominator and squishing them together, ripping them back apart. So it's two separate fractions each over the same denominator. And when we write it that way, it becomes pretty obvious here that we can cancel out the x's in the numerator and the denominator because they're multiplying and dividing. They're doing opposite operations. So either way you attack this, we're going to get to this solution here that we have a constant of 2.5, a numerator of 70, denominator of x. This tells me a couple things. I could actually start to graph this, and I'm actually going to use it to skip right on down to part C. We know that a denominator cannot equal 0, and that a denominator is what's going to tell me my vertical asymptote. So the fact that x cannot equal 0, that's our denominator, and that's our vertical asymptote, that makes sense because a vertical line is going to go through the x-axis. So if I were to start sketching the graph of what that might look like on a coordinate grid, I would have a vertical asymptote going right here through the origin where x equals 0. It's the constant that tells us the horizontal asymptote, and in this case it's a positive 2.5. That's what's telling my horizontal asymptote. We see it a lot more clearly when it's written in this form than when it's written in this form. So that's why we did this first step here, to think about, hey, how could we rewrite this to split those two parts up? So a horizontal asymptote happening here at 2.5. So our graph is going to look like this. And so if we wanted to explain, and I know I skipped part B, I'll come right back to that. But if I want to explain what this horizontal asymptote means in the context of this situation, what it's saying is that I see this graph getting closer and closer to this horizontal asymptote. And I notice it gets closer the larger and larger x goes. So that horizontal asymptote has two parts to its meaning when we want to interpret it in context. It means the more x's we have, in this case the more shirts we are ordering, the closer the y, in this case the cost per t-shirt, the closer the cost per t-shirt gets to that horizontal asymptote, to $2.50. So that's how we're going to interpret this horizontal asymptote. The more and more x's we have, the closer and closer this y gets to 2.5. So the more shirts we order, the closer the cost per t-shirt gets to $2.50. Now I skipped this C of 50 until now. I don't know why I did, but I did. C of 50 tells me that this is my input of 50. Now when I'm thinking about what does it mean in this situation, I do want to calculate it first because it's nice to see what it is I'm calculating. So when I plug in 50 into the equation, 2.5 times 50 plus 70, all divided by 50. That is x, and x is in the numerator and the denominator. I want to actually figure out what this calculation is before I'm ready to interpret it. And I see that my answer is 3.9. What this tells me, I need an input and an output first of all. My input is 50, so x, the number of t-shirts. That's what I'm going to say first, is that when I order 50 t-shirts, the output, which is the cost per t-shirt, is $3.90. It is really important when we're interpreting what an expression like this means that we look at not only the input of 50, but the entire function, the value at that input. So our input of 50 gave us an output of 3.9. That tells me when I order 50 t-shirts, the cost per shirt is going to be $3.90. We need both parts as we explain what that means. All right, let's flip over and let's just take a look at number 7. I really like this one. This is almost like how when I was growing up as a kid, we'd go to concerts all the time in Chicago, and we'd try to get as many people as we could fit into the car because we were trying to split gas among lots of people. So the cost for attending a concert is $20 for gas to get there and $49.50 per person for a ticket. So this cost is the function of the number of tickets purchased. So maybe there's a possibility that if enough people chip in, they could get a bus to take them to the concert, and then nobody would have to worry about driving there and back or parking and all that kind of stuff. So the cost is a function of the number of tickets purchased and can be modeled by this flat rate for gas, this $49.50 per ticket, and then we would divide it for the total number of tickets that are purchased, the total number of people that are going. So first, if I need to find C of 8, this is telling me that we're going to purchase 8 tickets. So I might think about that first, about what does C of 8 mean in this situation. When 8 tickets are purchased. The output, the cost per ticket is, and I don't know that number, so I have to do the calculation. So let's plug 8 into our equation and let's see what our output is. We have 20 plus 49.50 per ticket. We're buying 8 tickets, and we're going to divide that total cost among the 8 tickets, or the 8 people going. So we have nothing but numbers. Let's plug some numbers into our equation. So if I bought 8 tickets, that'd be a total of $416 total. That's for the 20 bucks of gas for the bus that's going to take us there. And then the per ticket going on there, $49.50. But I need to divide that total among the 8 tickets that we've purchased. And so that means if I charge $52 a ticket, I can cover both the ticket and the gas to get there. So when 8 tickets are purchased, the cost per ticket is $52. If I bought more and more and more tickets, I could start to calculate some of these values down here. So I know we've done a lot of this by doing the actual division and breaking it into 2 fractions, a fraction and a constant. But we can also look at it this way. If I think about my graph, my vertical asymptote, I know that comes right from the denominator, where the denominator cannot equal 0. And in this case, the denominator is just x. So x cannot equal 0. There's our asymptote, our vertical asymptote that's happening. Another way to find our horizontal asymptote, if breaking it up into 2 separate fractions isn't working for you, another way is to try to have some kind of bigger and bigger number and see what some different values are. Now we know how many it is for 8 tickets, but what if we had some kind of big number? Like, what if x was like 800 tickets? What would our output be? So I'm going to just use our equation here. I'm going to type this all in on a single line so I can be efficient and use some items again. I've got 20 plus 49.50 times 800 tickets, and I'm going to divide that by 800, the number of tickets I'm ordering. And this one is $49.53 per ticket. But what if x is an even larger number? What if it's something like 80,000 tickets? So I'm going to take my previous entry and I'm going to insert a couple zeros in there. And now it's 80,000. Huh. 49.50. What if I order 8 million tickets? Huh. It's still 49.50. So by putting in larger and larger numbers, I can actually calculate what that horizontal asymptote is, and that's going to help me explain what that horizontal asymptote means in context. What I'm seeing is that the more and more I order, the closer and closer the price gets to $49.50. Now it's never going to go lower than that. I'm never going to get it lower than $49.50 per ticket. So when I explain what the horizontal asymptote means in this context, that's exactly what it is. The more tickets we order, the closer the cost per ticket gets to $49.50. So this one, I kind of took a different approach. Maybe if the division's not working for you, try plugging in some bigger and bigger numbers until you see something consistently happen. Go larger than what they're asking you and see what the output is. Alright, hope these videos were helpful. Good luck on that retake, friends. We'll see you soon.